Today we're going to be looking at inverse functions. First we're going to talk about just a quick definition. We talked about functions needed to pass the vertical line test. That means a vertical line would not intersect more than once. We have a horizontal line test, and that's to determine if a function is one-to-one. So if a function is one-to-one, it will pass the horizontal line test. So for instance, if we have this graph and it's just a parabola, this would be a function because vertical lines only intersect once, but if we were to draw a horizontal line across this graph, it would intersect more than once, so that we would say this is not one to one. And I know I wrote in yellow, but it says not one to one. If we look at another graph, so if we look at, let's say, this graph, this is an exponential decay. That's where we're going to be getting to next. If we were to draw a horizontal line across this graph at any point, it's only going to cross once, so this would be one-to-one. So it would be yes, one-to-one. Always the tricky one to look at is if I just give you a horizontal line itself. If I were to draw a horizontal line across a horizontal line, it would most surely intersect a whole bunch, so this would not be one-to-one. Okay, so that's just your quick definition of what one-to-one is. We're just going to looking at by using a horizontal line test. The next thing we're going to do is actually talk about inverses and graphing inverses. The way we notate an inverse, which we've looked at when we did matrices, so we notate an inverse using the -1. So if we're looking at the graph of f of x, and we want to graph its inverse, so then we would be looking to graph its inverse, which would be f inverse of x. Okay, so f of x is my function, f inverse of x is its inverse. So if we start by just graphing any old function, oh, let's say it looks like something like this. Okay, so if this is my function f of x, in order to graph a function, really the inverse is just switching the x and y values. So the basic definition of an inverse is the domain and range switch values, which is probably something good to write down. We'll add it up here, domain, which is our x, and range, switch. So that means my x and y values switch. When we look at a graph, so graphically, it's reflected across the line y equals x because those x and y values switch. So if you look at the line y equals x, that's this perfectly diagonal line. So if we're going to graph the inverse, everything is going to reflect across that line. So this point will be just on, this side. This point, if it goes perpendicular to my inverse, to my f of x line, it will go somewhere about here. And this one is just going to stay on there. So its inverse would be that graph. So that blue graph, ignoring my perpendicular line, that would be the inverse of f of x. All we did was reflect it across that line y equals x. If we were to look at the coordinate points, they would just switch places. So if this happened to be the point 3, 4, this here would be the point 4, 3. If this was -3, 1, this would be 1, -3. Use your imagination. If this was the point -4, -2, oops, I messed up my parentheses, then the blue one right below it would still be the point -4, would be, just kidding, if that was -4 and -4, it would still be the point -4 and -4 because it just mapped back onto itself. So you just switch the x and y values if you're looking at graphing it. So graphically, you just switch the domain and range. You take the points that you're given, switch x and y. If you're looking at the graph itself, it just reflects across the line y equals x. So it's that perfect mirror image along the diagonal line. Algebraically, when we look at writing an inverse, so if it wants you to write the equation of an inverse, so if it'll either say to find inverse, it'll also note it as f -1. it wants you to do it algebraically and show your work. So for instance, if we had the equation f of x equals x cubed minus 4, the first thing you're going to do, so if we write some steps, is you're going to change f of x to y. Just going to make it easier to work with. As you go through this, the f of x will kind of get in your way. Second thing you're going to do, because we switch our domain and range, those x and y values switch, you're going to switch x and y. You're not going to change anything else, you're just going to switch x and y. So here we're going to take this one. First we're going to make it y equals x cubed minus 4. Now we're going to switch x and y. So instead of y equals x cubed, it's going to be x equals y cubed minus 4. All we did was switch, make the y an x, and make the x a y. Now step 3 is going to be solve for y. So we need to add 4, so we'll have x plus 4 equals y cubed. In order to get y by itself, we're going to have to take the cube root, so y is equal to the cube root of x plus 4. Last thing we want to do is put it back into inverse notation. We know this is equal to the inverse, so we're going to say f inverse of x, because we started with f of x, so the inverse of f of x is the cube root of x plus 4. The thing you need to keep in mind is if you take an even root, you get a plus or minus. So I'll do one more with you just to give you an idea of what that looks like. Let me quickly get a different color here. So if we had f of x, so this is a new problem, equals x squared plus 2, then we would have y equals x squared plus 2. So x equals y squared plus 2. All I did was switch the x and y. Now we solve. X minus 2 equals y squared. So I'm going to square root and switch to my f inverse. So we've got f inverse of x. That's just replacing after I square root. That's replacing the y. So we know we're going to square root this side, but we need a plus or minus because it's a square root. Anytime it's a square root, fourth root, or sixth root, you'll have the plus or minus. Square root of x minus 2. And that would be your inverse. The last thing we're going to do is show inverse by composition. If two functions are inverses of each other, then when we compose them, we're going to get x. So we're going to give ourselves a little definition. If f of g of x equals x, then f of x and g of x are inverses. If we have f of x is x squared minus 9, and g of x is equal to the square root of x plus 9, we're going to do f of g of x. So that means I'm going to plug g of x into f of x. So instead of x squared, we're going to have the square root of x plus 9 squared minus 9, because I plugged g of x into f of x. If I square the square root, that just cancels out the square root. So the square root of x plus 9 squared is just x plus 9. Then we'll have minus 9. Then 9 minus 9 just equals x. So because f of g of x is equal to x, then we know f of x and g of x are inverses.